So the target learning objective for this lesson is how is energy classified and measured. So first we're going to discuss what is the difference between potential and kinetic energy. So potential energy is stored energy and it's the energy of the position. So if I hold an object really high, that's going to have high potential energy because that's a stored energy. So it's the energy of its actual position. Whereas kinetic energy is the energy in motion. So once the object is moving, it's going to have kinetic energy. And the faster the movement, the more kinetic energy something has. So as kinetic energy decreases, potential energy increases. So those two energies work hand in hand. When potential energy is high, kinetic energy is low. And when kinetic energy is high, potential energy is low. So how do we measure energy? We can measure energy through temperature. So temperature is just the average kinetic energy of molecules of a substance. And how those molecules are moving is how high the temperature is. So if the molecules are moving fast, we're going to have higher temperature. If it's moving slower, we're going to have lower temperature. On page 13 of your Earth Science reference table, we have a chart that looks like this. Here's a better image. Okay, so we have Fahrenheit, Celsius, and Kelvin, and we have temperature. The higher we are on this, the faster those molecules are moving. So higher up, the more energy emitted, and the lower up, the less energy emitted. Okay, so higher up, higher temperature, more energy, higher kinetic energy. Lower, less energy, lower kinetic energy. So absolute zero is going to be when we reach, notice that Kelvin is much higher numbers. Absolute zero is when the molecules completely stop. So absolute zero is 0 Kelvin. The next thing that we can do to measure energy is heat. So heat is the total energy of a substance measured in joules or calories. So again, this chart is going to be very important. We can use it to convert from Fahrenheit to Celsius or Celsius to Kelvin just by reading the number and looking to the chart. Most important thing about this is that the zeros right here is going up by ones right in the middle, and same with this one, but the first column, the Fahrenheit, is going to go up by 2. So it's something to be aware of. So important temperatures to know is that water boils at 212 Fahrenheit, 100 Celsius, and 373 Kelvin. And you can get that just by looking at your reference table, so you don't have to memorize that. Room temperature is 68, 20, and 293. And water freezes at 32, 0, and 273. So you're going to use this chart to figure out temperatures and use that also to convert.